Here in the portrait gallery, we can click on the different pictures as we imagine hanging them from two angled cords or strings. We can adjust the weight of the portrait with the weight slider. The weight is provided in newtons, so this is the force of gravity acting on the portrait. In the case of a 25 Newton painting, the mass would be about 2.5 kilograms, since the strength of the gravitational field on Earth is roughly 10 newtons per kilogram. We can adjust the angle of the two strings by using the sliders or by pulling on the tension vectors in the graphs at top. You'll notice as we change the angle of one of the cords, the other changes as well. Why is that? Well, when we hang a painting, the painting should be in equilibrium. This means that all the vertical forces and force components cancel, and all the horizontal forces and force components cancel. In this case, the two cords can each generate both horizontal and vertical forces on the painting. The horizontal forces applied by the two cords will always equal each other if the painting is in equilibrium. We can see this on the two graphs at top. Notice that T1x is always equal and opposite in value to T2x. The two vertical force components do not equal each other, and they do not cancel. They both point upward. But notice that if we add the two vertical force components, they exactly cancel the downward, and therefore negative, weight of the painting. If we hit the play button, we see that there is some maximum limit on the tension in the cords before they break. The tension in a given chord is the magnitude of the force vector represented in the relevant graph. We would calculate this tension by finding the hypotenuse of the right triangle made up of the x and y components of the force. It is important to realize that the tension vector shown here does not represent the length of the string or cord. Just because the vector has a big magnitude doesn't mean the cord is long. It could be a short, high-tension cord, or a long, low-tension cord, or any combination. On the other hand, the angle made by the tension vector is the same as the angle made by the string. This means we can use trigonometry in the Pythagorean theorem to navigate between force components and the force magnitude. In this simulation, we pretty much keep the portrait in equilibrium. However, if an unbalanced force were to arise, also known as a net force, then an acceleration would be produced. This is Newton's second law. When a cord breaks, this means the gravitational force is now unbalanced, and the painting will accelerate downward. Play around and see what you can find.